Hey, how are you doing? Well, this is going to be our last lesson of the year, and it's going to be a brief and minimal introduction to finding volumes of revolution. Now, there are multiple types of volume problems in calculus, and we would normally address a couple more of the types, and even with this type, we'd go into more um, detail, and we'd have a lot more time to practice and work together on these. So I say brief, it's still going to be kind of a lengthy lesson for today, but keep in mind, we would spend 3 to 4 days in class. So 4 90-minute blocks really working on and learning this. And so compared to that, it's kind of brief. But the first thing we're going to do is we're going to look at a few diagrams, which your teacher obviously doesn't draw very well. So I want to at least show you some decent diagrams before we go forward. So as it says, what we are doing is going to look at some diagrams that are well drawn, and then you'll see me limp along with my not very well drawn diagrams. But if we take a function f of x here, and you revolve f of x around the x-axis, you get a three-dimensional solid that you can kind of see here that would look like maybe a vase that's been turned sideways. And if you were to slice perpendicular to the x-axis, then you would get cross sections that look like coins here, where they would be circular. If you looked at them from the right side coming in, they would look like circles. And so those are called discs. We don't call them circles necessarily, although they are, but we're going to call this the disc method. And here is one where you've got a function. Instead of f of x, we're going to call it f of y. And then if you revolve it about the y-axis this way, then you're also going to get sort of a three-dimensional vase shape here. And again, if you've revolved it around the y-axis, then you make your cuts perpendicular to the y-axis, which gives you, again, cross sections that look circular. And so I would use the disc method. So the idea is to find the areas of all these very, very thin discs. And if you stack the areas like this, you'll eventually create volume. So it's like stacking a package of paper. One individual paper is so thin, you don't think about it having thickness. But if you keep putting papers on the stack, you do get a solid block of papers that does have clear volume. So when we revolve, like we have in this left-hand picture, when we revolve around a horizontal axis, we're going to integrate from left to right because we're going to stack our discs in there moving from left to right until the solid is filled with circles. If you revolve around the y-axis like you do in the second picture, we're going to revolve around the y-axis and you'll get circles that you can stack upward until you have a layer of circles of different widths that create volume. So that would be integrating with respect to y. Now, the second method we're going to work on is washer method. And so sometimes I call it the dime and the donut method, but really you should call it the disc method and the washer method. A washer is a little piece that you sometimes work with if you like to work with tools. You've seen washers. They're real thin little metal discs, metal discs with holes drilled in them. And so if you have separation between your axis of symmetry and this graph you'll see here, then your cross sections as you cut perpendicular to the x-axis are a thin disc with a hole drilled to the middle. So you see that hole drilled to the middle right there. That's called a washer, okay? So again, we would slide our washers in side by side by side by side, which means we would be integrating with respect to x. Now we've got two pictures here where we've revolved around the y-axis. And again, you can see like here I get this vase shape with a kind of a hole down the center of the vase. And so the cross section, this is a really nice diagram. The cross section again is a washer. And so again, if you stack your washers from bottom to top until you have enough washers to have created that interesting vase shape with the weird hole drilled through the middle, then you're going to have volume. And so when you stack from bottom to top, you're integrating with respect to y. So we're going to practice drawing a few. And drawing is not my forte, but there's good news in your future. Just hang in there with me. So we are going to, on all of these, look at the graph of y equals the square root of x as it goes from x equals 0 to x equals 4. X equals 4 is the vertical line that's going to kind of cut it off on the right-hand side. And so it would create an area here, a yellow area here. And I'm going to take that yellow area and revolve it about different lines to create three-dimensional solids. So if I start by revolving around the x-axis, you take the shape and revolve it this way. And so when you do, what happens is you essentially reflect this way, not perfect. And so you've got to imagine that you get a circular top like that, okay? So it kind of looks like a sideways odd shaped bowl, an unusual shaped bowl, or maybe in sort of an interesting drinking cup or like a cap that you could put on your head or something. So when you look at this, the axis of rotation here is horizontal. So I'm going to draw a cross section on this one. I just draw a single stripe or segment, which is going to represent a really thin rectangle, okay? And what I'm going to do is I'm going to take that cross section and I'm also going to revolve it about the x-axis. And if you can imagine, it'll create a circle. And so I know that my, again, axis is horizontal. The segment I rotate is vertical, and that's important because they're always going to be perpendicular. And I'm going to wind up getting a Washna disc. Sorry about that. So there's no hole in it. It's just one solid circle. Okay. So I have to think about it. If this is a really, this stripe or segment represents a really narrow rectangle, its width is measured left to right. So its thickness is dx, it's just a small change in x. I could also think of it as saying, oh, well, I would have to keep drawing vertical stripes from left to right in order to completely tile the yellow area, or I would have to stack in there a series of really thin discs in order to actually complete the entire volume. So if I'm moving left to right, then that means I'm integrating with respect to x. So this would be a dx problem when it's time to set up my integral, okay? And we'll come back to that and actually set some of these up, okay? But right now we're just kind of trying to limp through drawings. Now, on the same exact graph, I want to revolve about the y-axis. So when I revolve about the y-axis, then I'm going to create symmetry to either side of the y-axis. And again, it would kind of look like this. And you've got to imagine, again, that the base then becomes circular. You're also going to get kind of a circular shape here. So this reminds me of like a big round cake or something with a funnel-shaped hole drilled through the center of it, okay? So on this one, since you revolved around the vertical, you're going to draw a segment or a stripe that's horizontal because they've got to be perpendicular to each other. So the stripe that I'm going to draw is going to be anywhere from my curve on the left to my straight line on the right. And when I revolve it around, I don't know if you can imagine that if you took the stripe I've drawn and take it all the way around like that, what you would create would be a washer. All right. Now, you would have to draw multiple stripes moving your way up in order to tile the area, or you'd have to stack multiple washers from bottom to top to create the volume. And so whenever you're working your way bottom to top, you're talking about integrating with respect to Y, bottom to top Y. The dy also more precisely represents the thickness of that skinny little red rectangle that I just drew. We'll come back to that. I've got my sheet here so I don't bleed through all my papers. Isn't it lovely? Okay, so now I'm going to revolve this one about the line y equals 2. So the line y equals 2 is this horizontal line. And so I'm going to get symmetry with respect to the horizontal line. And it looks like it would kind of be like this. So this one's kind of going to look like the last one. So I've got to think about it revolving this way. And so I'm going to get kind of a circular bottom. And then again, it's going to look like some kind of a, I don't know, a sideways round cake with a funnel-shaped hole drilled into it going to this direction. So since my axis of symmetry is horizontal, the segment I draw has to be perpendicular. It has to be vertical. And it's going to go anywhere again inside your original area. Okay. Remember, this was my original area right here, but it's got to run vertically bottom to top. So you don't try to hit a particular X value. That's not what you're trying to do here. Okay. You could also draw your stripe right here. It doesn't matter where you draw it. But again, if you could imagine that stripe, which is separated from the axis of revolution, if you revolve around that axis, you're going to create a washer. And you're going to have to stack the washers that are coming around like this. You're going to have to stack them left to right to fill the volume. So if I go left to right, that's dx. And again, you're saying the thickness of either one of these stripes, these little tiny skinny rectangles, the thickness spreads out in the left to right X direction. So I know it's really hard to learn some of this without I've got some really cool software that shows this well at school, but I can't get it to work here at my house. And so I know it's hard to learn some of this at home, especially when you're stuck with my drawing skills, but we'll survive this. All right, so on this one, I'm going to revolve about the line x equals 4. That's my vertical line here. This one I think is a little easier. So I'm going to create symmetry with respect to that vertical line. And then when I revolve this way again, I get kind of that mound shape. Actually, you know what that kind of looks like? A contact lens that's sitting upside down. It's kind of what that reminds me of. It's a dome shape, maybe you could say like that, or like a little skull cap kind of thing. So again, I'm revolving around the vertical. So the segment or the skinny rectangle I'm going to revolve is going to be horizontal. So here's my original graph right here, right? My original area. So pick a place like that. And again, if it's touching, if the segment you draw is touching the axis of symmetry, when you revolve around the axis, not symmetry, but axis of revolution, what you're going to get is a disc. It's going to be a circle with no hole in the middle. Now, I'm going to have to stack those circles which go this way. I'm going to have to stack them one on top of the other to completely fill the volume. That means I'm going to be differentiating with respect to y. So 2 more. Now on this one, I'm going to revolve about the line y equals -2. Y equals -2 again is a horizontal. Ooh, that's going to give me some separation there. So let's see here. If I do symmetry, that looks like the symmetric shape would look like that. And if I revolve it, I have not done a bang up job drawing this. But what it looks like now is, again, sort of like you've got a wedge of stuff, but you've drilled a cylindrical hole straight through the middle, because the cylindrical hole is going to be the same width the entire way. So since my, again, axis of revolution was horizontal, the stripe, the segment that I draw within my original area is going to be vertical. And so it can be anywhere, just pick somewhere. So remember, here was my original area. So there's my little vertical, I'm calling it a stripe or a segment. It's really supposed to be a really narrow rectangle. So if you can imagine, it's separated. There's space between my vertical segment and the horizontal revolution axis. So when I come around, and that wasn't the best way to say that, but when I come around, I'm going to get a circular pattern, but it's going to have a hole in the middle. So it's going to be a washer. I'm going to have to stack those washers in there tightly from side to side to fill the whole volume. So I'm moving left to right. That means I'm integrating with respect to X. So it's going to be a dx problem. All right, last but not least on my drawing, I'm going to revolve about the line X equals 5. So I'm revolving about a vertical line. Let me get some symmetry going here. I'm not going to do a lot of counting, just going to eyeball it. So this is going to be the exact same kind of shape. I might wind up drawing this one better. So when I revolve this way, I get that cylindrical shape through the middle, and the bottom becomes perfectly circular with the hole drilled out. So again, it's the exact same shape. It's some sort of a dome or something with a cylindrical hole drilled right through the middle. A tube has been pushed through the middle. So on that one, since I revolved around the vertical, then I need to make my little stripe or my thin rectangle horizontal. Remember, here was my original graph. So I'm going to just pick some kind of a horizontal stripe in there. And again, if I revolve it all the way around, I'm going to get a washer because it's going to have a hole in it. I'm going to have to stack those washers upward. Okay, so that means I'm working from bottom to top, which means I'm going to integrate with respect to Y. So here's the really good news. You don't have to be able to draw the three-dimensional solid. Because if you did, I would get to a certain point with this and I wouldn't be able to go any further because you know that my drawing skills are fairly limited. Limited. It's a calculus class. We like to talk about limits. That's one of mine. But what you do need to draw is just the original area, and you need to think about what the axis of revolution looks like so that you can draw the one segment that's going to be perpendicular to the axis of revolution. And then from there, I think you can imagine whether it's going to be a disc or washer without actually having to draw the 3D figure, which is cool. So if the cross section's a disc, it's a perfect circle, and its area is just pi r squared. And the radius usually has, not usually, always has the initial equations that you were dealing with in the radius length, okay? If your cross section is a circle with a hole in the middle, it's a washer. Well, in geometry, if I said, well, find the area of the yellow region, you would have simply said, well, let me find the area of the whole big circle minus the area of the little white circle. So I always say that's big area minus little area, area of big circle minus area of little circle. So it's going to be area of pi r squared, where the first r is the radius of the big circle, minus pi r squared, where the second radius is the area of the little circle. So you'll hear me say pi outer radius squared minus pi inner radius squared when we're actually doing the problems. So again, the big detail that I just mentioned, once you have your axis of revolution, when you draw the segment, it's got to be perpendicular. So if it's a vertical axis of revolution, the segment that you draw is horizontal. If it's a horizontal axis of revolution, the segment you draw is vertical. Now we're going to set up some problems so you can actually start to see how this works, okay? So I just said on this one, imagine if you rotated that vertical segment, this red segment, that you would get a disk, which is a circle. So the area of the disk is pi r squared. Guys, the basic idea is if you integrate area, you get volume. So I'm going to say I've got to integrate with respect to x. So the volume, I don't know if you can see that, is the integral of pi r squared dx. I've already figured out it's dx. Now, if I'm integrating from left to right, I need to know that my yellow region starts on the left x of 0, so that's your lower limit, and it goes to the right x. Well, the right x is 4, so that's your upper limit, okay? So now I'm going to say volume equals. Now, if you want to pull the pi to the outside, you can. I will usually do that. And I need to decide what r squared is. So I've got a space for r squared, and I'm going to fill in r. Well, guys, r is this length. Now, let me tell you on this one, I'm trying to find the marker that maybe is going to write a little bit brighter for me. Let's see here. But on this one, since your length is vertical, then to find the vertical radius, this is my goofy way of remembering it, you need to think of a vertical as being high y minus low y in order to find that vertical length. Well, the high y is right here, okay? And that high y is y equals the square root of x. So that's here, minus low y. Well, your low y is the bottom y value. Well, that falls along the line y equals 0, the x-axis. So your low y is 0. Okay, so now if you work that out, you're going to say, well, the square root of x minus 0 is just the square root of x. Squared is just x dx. Well, holy moly, that's no longer a real difficult problem. So when I integrate or I do the antiderivative of x, I get 1/2 x squared. I need to go from 0 to 4. I'm going to make that pi times 1/2. I'm going to make it pi over 2. And then I'm going to say, well, that would be 4 squared minus 0 squared. And of course, that's just 16. So pi over 2 times 16 is equal to 8 pi. And it would be units squared. If you're not given units, don't feel like you need to guess at the units, okay? So that was not so bad. Now, let me jump into one that's a little harder, okay? And we're not going to finish all of these. A lot of these, if you can get them set up, they're messy to work out sometimes, but a lot of times you actually are just asked to choose the correct setup, which is cool. Let me see if maybe just using a dark pencil will show up better for you, okay? So on this one, I know that when I rotate this, I'm going to get a washer. And I've already said the area of the washer is going to be pi r squared minus pi r squared. And I'm being a little loose with my notation, but the first radius is the outside radius, the radius of the big circle. And the second radius is the inside radius, the radius of the little circle, okay? So I also want you to recognize that if your links are sideways or horizontal, then to find this length, you have to say right x minus left x. okay? Now, what I'm going to do is say the volume is going to be, and I'm going to have to say pi r squared minus pi r squared, and then dy. I had already figured out I was going to integrate with respect to y. That means I've got to integrate from my lowest y. Well, my lowest y is right here at y equals 0, to my highest y. On this original graph right here, the highest y was this point, which is 4, 2. Because remember, my original equation was y equals the square root of x. So if you plug in 4 for x, the square root of 4 is 2 for y. So this is 4, 2. So my highest y is 2. And I put that right there, okay? So I can, again, if you want to factor out the pi, you can. You don't have to, but you can. Why don't we not do that this time, just so you can get a feel for it? So I'm going to say pi r squared minus pi r squared dy. So what I've got to do is figure out big radius minus little radius. So here's what I want to measure. Hopefully you'll be able to see this. Now, the axis of revolution is the y-axis. So I need to measure from the axis of revolution to the point on the stripe furthest away, which would be right here, okay? So that would be my outer radius. Well, my right x is over here at x equals 4. My left x is right here, and that would be at x equals 0. So 4 minus 0 goes there, okay? Now, my inner radius goes from this point on my axis of revolution to the closer point on the stripe that I'm rotating. So to find this green radius, I need to say right x minus left x, okay? Well, the left x is still 0, so I still want to say minus 0. But the right x, now, this is where you have to say, if y equals the square root of x, then x would be y squared. I just squared both sides. So the x that goes right here would be the one on the curve. So it's x equals y squared. All righty. So that's a little different. So I'm going to say the volume equals, I'll factor out the pi now. Pi, 0 to 2, 4 minus 0 is 4, squared is 16, minus y squared minus 0 is y squared, squared again is y to the 4th, dy. Now notice when I said this is right x minus left x, my right and left x's wound up being in terms of y, which then makes sense because if I've got all these y terms in here, I'm going to have a dy on the outside. That's the way that's going to work. So anyway, now this doesn't look too bad to integrate. So I'm going to say that's pi. The antiderivative of 16 with respect to y is 16y. Minus the antiderivative of y to the 4th is 1/5 y to the 5th. And I need to take it from 0 to 2. So I've got pi. When I plug in 2, I'm going to have 16 times 2 is 32. When I plug in 2 to the 5th, I get 32 times the 5th is 32 fifths. And then when I plug in 0, I'm just going to have 0. So it's understood to be minus 0. So I need to clean up what I've got. Multiply by 32 by 5 over 5, and you're going to get 160 over 5. Minus 32 over 5. 160 minus 32, I believe, is 128 over 5. And if it's 128 over 5 times pi, I'm going to go ahead and say it's 128 pi over 5 units squared, whatever my units are. I'm going to skip a little bit. Let's go to this one that I said kind of looked like a contact lens that had been laid upside down. All right, so again, since our axis of revolution was vertical, we drew a horizontal segment, and we're going to rotate that horizontal segment this way, and it's going to create a circle. And the circle is going to be a disk, and the areas of disks are just pi r squared. So to find the volume, I'm going to say I need to integrate pi r squared, and then it's going to be a dy problem. So again, that means when I sub in for r, my expression is going to have y's in it because it's dy. But now let's go back and think. Since the segment's horizontal, to find lengths, horizontal is going to be right x minus left x. And I apologize if that the video looks backward to you. So right x minus left x. That's the way I'm going to figure out. Okay, so what I'm going to do is say, oh, and I've got to figure out, again, my limits. Well, remember, I'm still going from a low y of 0. My high y is here, and that's at the point 4, 2. So my high y is still 2. So I've got that. So getting your limits of integration is part of your credit when you look at these. All right, a lot of times the way you'll be scored is, did you get the limits of integration correct? Did you get the integrand correct? Okay, so that means your integrand has correctly be in terms of x's or y's with the correct expression. Anywho, I'm going to say pi times 0 to 2 r squared dy. Okay, so I just have to figure out what's my r squared. Well, I have to start with this segment, okay? The axis of rotation's here. So I'm going to have to go from this right y there to my left y there. I don't have to do big minus little, just right minus left because I don't have a washer. It's not a big r squared minus a little r squared. Well, my right x is just x equals 4. My left x, well, is the left, it's the x that's on the curve itself. Remember, the curve is y equals the square root of x. And if you're trying to get in left x equals, then you're going to say x equals y squared. So your left x is equal to y squared. Okay? So now I'm set up and ready to go. But I need to make sure you understand I've got to square 4 minus y squared, squared. So that means I'm going to square it quickly and get a trinomial. So 4 squared 16 minus 4 times y squared is 4y squared, and you double it, so it's 8y squared, plus y squared squared, y to the 4th. dy. Now we do antiderivatives. So it's going to be pi times the antiderivative of 16 is 16y minus the antiderivative of 8y squared is 8y to the 3rd over 3. So it's going to be 8/3 y to the 3rd. And here you're going to take it up to y to the 5th and divide by 5. So it's going to be 1/5 y to the 5th. Then I need to plug in my 2 and work it out. So I'm not going to go all the way with that one, just part of the way. All right, so we're going to look at just setting this one up. We're not going to totally work this one out either, because I think once you see how to work out a couple, it's just a matter of practicing and being careful. And you all know how to do antiderivatives and plug in. So the focus is more on setting these things up. And I realized when I look back at it, apparently I didn't count it right very correctly because I thought it really doesn't look symmetric. Well, the dotted line is 2 units to here, and I should have said 1, 2, and then drawn the other edge. I messed up. But fortunately, you don't have to draw the figure correctly to do the work correctly. So let's just focus on my original graph, which is right there. and the fact that the axis of revolution is horizontal. And so I drew that red stripe in there, my thin rectangle vertically. And so consider that to find length in a vertical direction, you go high Y minus low Y. So I'm just going to remind you, my lengths are going to be high Y minus low Y when I set it up, okay? So that means I'm going to be stacking from left to right, which is a dx, and I already knew that. So the volume is going to be, I'm going to have to do, since it's a washer, the area of the big circle pi r squared minus the area of the smaller circle, which is also pi r squared, in dx, all right, end with the dx because you're integrating with respect to x. Now, if I'm integrating with respect to x, I need my leftmost x and my rightmost x. My leftmost x is 0. My rightmost x is the x coordinate of this point, which is 4, 2. So my rightmost x is 4. Okay. So now when I set it up, I've got 0 to 4. I'm going to say pi r squared minus pi r squared dx. So the challenge is figuring out how to name your outer radius and your inner radius. So guys, what you need to do is you need to imagine now this radius, and it's going all the way to that axis of revolution. So my outer radius is from this point on the axis of revolution to the outermost point on that segment. So my outer radius would measure that vertical length, okay? So when I do that, I have to say high y. Well, the y is the y on the curve, and the curve is y equals the square root of x. So my high y is the square root of x minus. Now my low y is down here, and that's at y equals -2. So minus y equals -2 minus -2 is +2. Okay? Now I'm going to find my inner radius. So the inner radius goes from the axis of revolution to the closer point on that segment. So my inner radius would measure that distance. Now, that would be the length of the dotted line, the dotted vertical. Well, my high y is just at y equals 0. My low y, again, is y equals -2. So it's still going to be 0 minus a -2, which is 0 plus 2. That's just saying that this is a constant distance no matter where you measure it. No matter where you measure it, it's a constant distance of 2. So guys, on this one, I would need to square this trinomial, the square root of x plus 2 squared. Here, I'm just going to say 0 plus 2 is 2, squared is 4. So I'm going to say pi times whatever this is minus 4 pi. Or what would be even better when I go to work it out is to factor the pi out. All right, last but not least on this example, and then I'm going to get you into 4 more that we're going to do with a common curve with less, the pictures won't be as dense, okay? So on this one, my axis of symmetry was vertical. Inside my original area shape, which is right here, that was my original area. I draw the stripe inside the original area if you want to keep it the simplest, okay? I drew a stripe or a skinny rectangle in the horizontal direction. When I rotate it, it's going to be a washer. That tells me that my volume is going to be the antiderivative, and the area of washers is pi r squared minus pi r squared. And I already know it's going to be dy. If it's going to be dy, then I have to go from a low to a high y. Remember, my low y is y equals 0 at the point 0, 0. The high y is 2 at the point 4, 2. Okay. On this one, I'm going to go ahead and factor out the pi because I haven't done that. And that way you see it in action. But I still have to do r squared minus r squared dy. So I always kind of build the shell, and then I figure out what to do to complete the shell. Now I notice that my segment is going to be horizontal, and to find the length of a horizontal, you have to do right x minus left x. Okay, so when I look at right x, guys, again, imagine that you extend the solid radius onto the axis of revolution. The outer radius goes from the axis of revolution to the furthest point on that red segment. So that would be right there. You're going to be measuring that big width. So your right x, the right x is here, which is x equals 5, minus, now I need my left x. My left x is here on the curve. So remember, the curve is y equals square root x. So the left x is x equals y squared. So it's 5 minus y squared. That's your left x, okay? Now, I also need to do inner radius. Inner radius goes from the axis of revolution, so from here, to the point that's closest on that red segment. That's here. So your inner radius goes from a right x of 5 to the left x, and the left x is on that vertical line, which is x equals 4. So here you're just going to have 5 minus 4, and that's it. And then you would start working it out from there. All right, so now we're going to start a whole new problem. We're going to do the same graph rotated in different ways so you can see. Sometimes I think you learn more when you take something simple and you rotate it different ways and see how differently it can cause the setup to be, that's actually more instructive. So we're going to start out with y equals 1/2 x squared and y equals 2x. We're going to see how they intersect so we can enclose an area, and then we're going to rotate the area. So I'll actually draw this first one here with a black marker. So again, I'm not going to draw it perfectly. I'll draw a little bit better the first time, but after that, I don't need to draw all that well, okay? So I know that I'm going to tackle the easier one first, that y equals 2x is just a line with a y-intercept at 0, and the slope is up to right 1. Okay, so I could come on down into the third quadrant, but I know that y equals 1/2 x squared sits at the origin and opens up from there. So I know that this graph is only going to be contained in the first and second quadrants. So what I'm going to do is say, okay, well, this parabola starts at 0, 0. I know if I plugged in x equals 1, I'd get a half. So it's going to be a little bit wider. Now, I'm just going to draw the basic shape. So it's going to look like that. So the area that's contained between the two curves is that area, okay? Now we're not drawing segments yet because we're not rotating, but this is the area I'm going to draw over and over again. I'm not even going to attempt to draw the 3D solids because number one, I don't draw so well. Number two, I don't have to. I can figure out what I'm doing without that, okay? But now I do need to know what my limits of integration are. So I need to know both points of intersection. Well, it's pretty clear that this point of intersection down here is just 0, 0. That's not a big deal. To find the other point of intersection, you need to see where these two graphs cross each other. And so the easiest thing to do is just set them equal to each other. You didn't see as much of this since we didn't do a whole lot of the area between two curves. So we're kind of picking it up now. Tell you what, I'm going to clear the fractions because I can. So let me multiply 3 by 2. I'm going to get x squared equals 4x. I know that when I solve any polynomial equation, I pull everything over to the left, 0 on the right. I'm going to factor. x equals 0, x equals 4. I knew one point of intersection was at x equals 0. So this other point of intersection is at x equals 4. Uh-oh, 4 comma what? Well, it doesn't matter if you plug it into y equals 1/2 x squared. Y equals 1/2 times 4 squared will be half of 16 is 8. Or if you plug it into y equals 2 times x, because 2 times 4 also gives you 8. So to find the y coordinate for the point of intersection, plug it into either of your initial equations for y equals. So now I've got that part. All right, it's a good thing I paused the recording because my camera went out of focus. All right, so I'm going to revolve about the y-axis. So my axis of revolution is vertical, so that means I need to revolve a horizontal segment. So any horizontal segment will do. It doesn't matter if you draw your horizontal segment down here or up there. All horizontal segments are going to be separated from the axis of revolution. So if you take something that's separated around the axis of revolution, it creates a washer. All right. So if I've got a washer, I know that my volume is going to be pi r squared minus pi r squared. Now, I've got to think, if I'm going to keep drawing stripes, I'm moving my stripes from bottom to top, which is dy. And if I'm going in the y direction, my limits have to be my low y and my high y. Well, my low y is 0, 0, so it's the y coordinate of 0, 0. My high point is 4, 8, so the y coordinate is 8. So now I've got it sort of set up. Now let me create a shell. I think I'm going to go ahead and factor out the pi. So now I have to do outer r squared minus inner r squared. Okay, so I've got my shell set up. Now I notice that my segments are horizontal, and if you're measuring the length of a horizontal segment, you have to say right x minus left x. So I'm going to remind myself that it's right x minus left x. Okay, so that means I'm going to have to take my equations, and instead of writing them in y equals format, I'm going to have to write them in x equals format. So remember, this equation's y equals 2x. Okay, so if I isolate x, x is going to be 1/2 y. So one of my right and left x's is going to be 1/2 y likely. Now, my second equation was y equals 1/2 x squared. So if I multiply through by 2, I get 2y equals x squared. And you don't need to get real particular with this most of the time. X is going to be the square root of 2y. Plus or minus the square root, but most of the time you don't have to worry that much about it because you're going to square it and it'll sort of takes care of itself. But I'm going to look at it now, and I've got to be more specific. So imagine I'm going to use this one right here. Let me go all the way to the axis of revolution, because I need to measure outer will be from the axis of revolution to the point that's furthest away on that red segment, okay? So I need right x. Right x is going to be the x on the curve. So that's going to be the square root of 2i. Left x will be here, and that's just x equals 0. Got that? Now, I'm also going to measure right x minus left x on the inner radius. The inner radius goes from the axis of revolution to the point on that red segment that's closer. So I need to measure this part, okay? Well, the right x here is the x along the line, which is 1/2 y. Left x again is the x on the axis, that's 0. Now, there's no there's no, you always say curve minus axis of revolution. That's not true. It matters their position right and left, okay? So that you're gonna have to go picture by picture to see which one is actually right, which one's actually left. So don't try to make too hard and fast a rule on that part. So now, if I want to actually work it out, I'm not gonna work out all these, but we'll work out this one. I've got pi from 0 to 8. Now, square root of 2y minus 0 is the square root of 2y. Square the square root of 2y and you just get 2y. Cool. Minus 1/2 y minus 0 is just 1/2 y. Square the 1/2 y and you get 1/4 y squared. dy. Okay. So now I begin my antiderivatives. The antiderivative of 2y is y squared minus 1/4. The antiderivative of y squared is 1/3 y cubed. I'm going to go from 0 to 8. You'll see I'll do some calculations. Most of these you'll try to do by hand, but on this year's AP exam, you're allowed to use a calculator. Even if you don't use a graphing calculator, you can still use one to just deal with your numbers. So plug in 8 squared 64, minus 1/4 times 1/3, 8 cubed. What is 8 cubed? I think it's 512. So it is. And then when you plug in minus 0 squared minus 1/4, 1/3 y cubed, that's just 0. So I'm not going to worry about that part. So you might say, why didn't you make this 1/12? Because I anticipated that 4 was going to go into the 8 cubed. How many times does 4 go into 512? Let's see here. 4 goes into 512, I think 128 times. I am checking where I've already worked this out. And then it's over 3. So I need to get a common denominator. So multiply 64 by 3 over 3, and I believe you get 192 over 3 minus 128 over 3. Yes, I just checked where I'd already worked it out. 192 minus 128 is actually 64. So I get 64 thirds on the inside times pi. I'm going to go ahead and just make it 64 pi over 3. And again, units cubed. Did I say units squared earlier in the video? If I did, I'm sorry about that. Units cubed. I may have said that. Oops. So let me show you something real quick. I'm going to set my calculator up for you. All right. So I keep going in and out of focus. Notice the original equation I'm actually integrating is 2y minus 1/4 y squared. Now, your calculator doesn't know if you're working in y's or x's. So if you go, I'm trying to figure out how to hold it so you can see it. I'm saying it's 2x minus 1/4 0.25 x squared. So that's the equation I want to integrate. Now, if you go to your home screen, so I'm going to do second quit. I'm going to clear out of there. What I want to do is pi, so second pi, times the integral. So I'm going to do my nderiv. So math, choice 9 is nderiv. My limits were 0 and 8, so 0 on the bottom and 8 on the top. I've already taken time to enter of my y, my equation in y sub 1. So I find that I feel a little more safe plugging it, taking my time and entering it once really well in y sub 1, and then just entering y sub 1 on my home screen. Now, you always integrate with respect to x right now because your y1 was entered in terms of x's. So when you do that, what you've done is set up the same problem that we just did by hand. Now that gives me 67 point yada yada. Well, a minute ago, our answer was 64 pi over 3. So 64 times pi, nope, that says times e, times pi, nope. Let's just try that again. 64 times pi divided by 3. And that gives me the 67 point yada yada. So I can do these. Some of these would be, if it was a normal year, would be on the calculator section of the test. So once you set up the very first integral, like once I set this up, I could actually hit it and go straight from there to the answer on the calculator. But at least you could check your answer and make sure you've done all your algebra work by hand correctly. So now let's, oh, sorry about that. Didn't mean to make you seasick. On this one, we are going to set it up, but we won't work it all the way out. But I do want to make the point that it's a brand new problem. I draw a brand new picture. But Miss Porter, I know you don't love drawing brand new pictures, but it does kind of help. Now, one thing I've noticed is sometimes my pictures are easier to figure out inner outer if I kind of over exaggerate the shape of the area. So I'm kind of exaggerating quite a bit. So here's the area. So whenever I draw my segment, I have to draw it within that yellow shape. So about the x-axis, so this time my axis of revolution is horizontal, which means I need to draw a vertical stripe, okay? So I know that if I revolve that vertical stripe around, it's going to be a washer, which tells me I'm going to start with volume equals pi r squared minus pi r squared. Now, you might say, do you have to write that step every time? No, I'm trying to be real specific with you since we're at a distance from each other. All right, now, wait a minute. Is it a dx or a dy problem? Well, remember, I would have to draw multiple red stripes in order to finally tile the area. So if I drew multiple red stripes side by side, I'd be working from left to right, which means I'm going to integrate with respect to x. Now, if I'm going to integrate with respect to x, I need my left x and my right x to be my low and high limits of integration. So remember, this point is 0, 0. So my left x is 0. Remember, this point was 4, 8. So my right x is 4. I also want to remind you that if you find links in a vertical direction, your links are going to be high. When you find links in a low vertical direction, it's high y minus low y. Okay, so I am going to factor the pi to the front. Yeah, that's not pi, that's 4. See, even on video, I'm still making my same goofy, that was my auditory eraser that I just used. So r squared minus r squared dx, okay? So I'm going to have high y minus low y, but remember when I say y equals, it's going to be in terms of x's, and that's why you've got a dx on the end. So let me do high. So if I extend, then I'm going to go from the axis of revolution to the point that's furthest away on the red stripe, that's there. So my outer radius is there. So high y is the y of the line, that's y equals 2x. Low y is the y that sits on the x-axis, that's y equals 0. Now, my inner radius is going to go from my axis of revolution to the point that's closer on that red stripe. So that's going to be, this length is going to be inner radius. So the high y is the y on the curve. That's this 1/2 x squared. I about forgot which problem I was on. My low y again is just going to be my 0. That's all I'm going to do on that one. I'm going to go to the next problem. Last 2 examples. Yes, I'm redrawing the picture. So here I go. I know I have a straight line, and the straight line hovers above the curved parabola. I know this point's 4, 8. You do not need to get a different color marker and shade in the area. I just want to remind you that when you draw your segment that revolves, it's got to be in the yellow area if you want to keep it simple. Now, y equals -1. is going to be this horizontal line. So that means that you're going to revolve a vertical. Again, since the vertical line is separated from the horizontal axis of revolution, it's going to be a washer, okay? So volume is going to be pi r squared minus pi r squared. Now, do you see that again, if I drew multiple vertical lines, I would have to move my way left to right in order to tile the yellow area. So if I'm moving left to right, I'm integrating with respect to x. My first or leftmost x is 0. My second or rightmost x is 4. So I'm starting to get a little faster here, hopefully, and I know you're getting worn out because this is a lot. Now, I've got to do high y minus low y because it's vertical. So let me figure out outer radius. So the axis of revolution is here. Outer radius goes from the axis of revolution to the point that's furthest away on that red stripe. So what I've done in dark purple is the outer radius, okay? So again, my high y here is the y on the line. That's y equals 2x. My low y is the y on the dotted line. That's y equals -1. So I'm going to say 2x minus -1 is 2x plus 1, okay? Now, for the inner radius, you measure from the axis of revolution to the point on the red stripe that's closer, so that's here. So my inner radius is going to be that sort of blue distance, okay? On this one, the high y right here is the y on the curve, so that's 1/2 x squared, minus the low y is the y on the dotted line, so that's y equals -1. So minus a -1 is once more plus 1. So if I were to work this out, I would go ahead and get the pi's to the front to keep it simple. I'm going to have to square 2x plus 1. So it would be 4x squared plus 2x times 1 is 2x, doubled is 4x, plus 1 squared. Then I'm going to have to square 1/2 x squared plus 1 and subtract as I go because it's minus. So square the 1/2 x squared, that's going to give me 1/4 x to the 4th, and I'm going to subtract it. 1/2 x squared times 1 is 1/2 x squared. Doubled is 1x squared. Subtract it. 1 squared is 1. Subtract it. Dx. Now this is if I have to work it out by hand. You might well just be asked to set something up, remember. But I'm going through steps to figure out how to get it cleaned up, so I've got a chance at working it out by hand correctly. So let's see here, 4x squared minus x squared is 3x squared. Then I've got 4x, I don't see anything else that goes with the 4x. Notice I've got plus 1 and minus 1, they cancel, thank goodness, that's one less thing to worry about. And then minus 1/4 x to the 4th. Now I could start my antiderivatives. So of course, I would take that to x cubed and then divide by 3. Put my pi in there. 4x, the antiderivative would be x squared, and it would be 4/2, which of course you'll make 2. Minus 1/4 x. I'm going to take my x to the 4th to x to the 5th. So it'd be times 1/5. That's it on my antiderivatives. I'm going to go from 0 to 4, and I'm going to work it out from there. Okay, I'm not going to show that right now. So let's do the last problem, mainly just showing you how to set these up and then get you to the point where I think you could finish working them out by just plugging in and cleaning up. All right, so one more time, I'm going to draw the picture. A lot of times I will shade, but you don't have to do that. That's not really a requirement. Usually I'll do it in real light pencil. Now I'm revolving around x equals -2. That's a vertical line. I was going to revolve around x equals -1 and decided to change it. Since my axis of revolution is vertical, pick any rectangle. That rectangle will be horizontal. The rectangle is separated from the axis of revolution, so I know it's going to be a washer. That means I'm going to integrate the area of a washer is pi r squared minus pi r squared. Oh, I was about to put in D something. I've not thought about it. Guys, remember, if you have to keep stacking the horizontal washers from bottom to top, you're integrating with respect to y. So I need to go from low y to high y is 8. Now, the length of a horizontal is right x minus left x. I want to remind you that one of our equations was y equals 2x, so that would be x equals 1/2 y. One of our equations was y equals, oh, that's almost all screen, 1/2 x squared, so 2y equals x squared. X equals the square root of 2y, technically plus or minus the square root of 2y, but that generally sort of takes care of itself. Okay, so when I look at extending that segment I'm revolving all the way to the axis of revolution, outer radius goes from the axis of revolution to the point furthest away. So I need to find that big purple distance. So right x is the x on the curve. The x on the curve is the square root of 2y. Left x is the x on the vertical line. That's x equals -2. So the square root of 2y minus a -2 would be +2. And then on my inner radius, I go from the axis of revolution to the point on the red segment that's closer. Okay, so my inner radius would be that blue distance I just drew. Right x is the x on the line, so that is the x equals 1/2 y. Left x is the x on the vertical line here, which is x equals -2, so minus a -2, okay? And then I would need to square both of these. I do want to show you one thing that I want you to see. So I'm going to work this a little bit of the way. I factored out the pi. Now, I need to square this binomial. The square root of 2y, the square of that is 2y. When I multiply these, I get 2 times the square root. You have to double it, so that would be 4 times the square root. Plus the square of the 2, so plus 4. Minus. Now, I need to square this binomial as well, so square the first, that's 1/4 y squared. Multiply these by each other, so 2 times 1/2 y is 1y doubled is 2y. 2 squared is 4. No, not right now. That's dy. So now let me clean some of this up. There's one part I'm wanting you to see. So let's see here. I've got 2y, oh good, minus 2y. Thank goodness a little of it cleans up. I've got 4 square root 2y. Let's see here. I've got 4 minus 4, so good, something else cleans up. Minus 1/4 y squared. Now, people get confused when they do the antiderivative here. You don't need U substitution. Let me rewrite this. Instead of saying 4 square root 2y, let me rewrite it as 4 square root 2 square root y, okay? And that's going to be 4 square root 2 y to the 1/2, okay? That's much easier to integrate, okay? Then you're going to have pi 4 square root 2. When you integrate the y to the 1/2, it's going to be y to the 3/2, and then you put 2/3 right there, okay? Minus 1/4. And when, of course, you integrate y squared, that's 1/3 y cubed. You're going to plug in 0 and 8. You'll clean all this up. You don't need this anymore. And you go from there, and you're done. So good luck. You've got a few practice problems. And as always, I know this is like really tough when you first start. At first, people get really nervous, but then when you start doing it, people all of a sudden, the learning curve is very quick. So I'm on Zoom, though, as always. Come ask for help, and happy volume finding.